In TypeScript, a user-defined type guard is a function that determines the type of an object at runtime. It allows the TypeScript compiler to make more accurate type inferences based on the results of these functions. To define a user-defined type guard, you can create a function that returns a Boolean value and use it in a type assertion. The function should take an input parameter that represents the value whose type needs to be determined. The return value of the function should be a Boolean that indicates whether the value matches a certain type. For example, suppose you have an interface called cat. You can define a user-defined type guard for this interface as follows. This function checks if the input object has a name property and a meow method. If it does, it returns true, indicating that the object is of type cat. Otherwise, it returns false. You can then use this function to perform a type assertion on an object. The isCat function is used to check if my pet is a cat. If it is, the type of my pet is narrowed to cat within the if block, allowing you to access the meow method without a compilation error. Here are some additional features that can be used with user-defined type guards in TypeScript. Type-off type guards. TypeScript has built-in support for type guards based on the type-off operator. For example, you can define a type guard for a string as follows. This function checks if the input value is a string and returns true if it is. You can use this function to narrow the type of a variable or parameter to a string. Instanceif type guards. TypeScript also has built-in support for type guards based on the instanceif operator. For example, you can define a type guard for a date object as follows. This function checks if the input value is an instance of the date class and returns true if it is. You can use this function to narrow the type of a variable or parameter to a date object. Intersection type guards. You can use intersection types to create more complex type guards that combine multiple conditions. For example, suppose you have an interface for a person that can be either a student or a teacher. You can define a type guard that checks if a person object has a student ID property and use it to narrow the type of a variable or parameter to a student. This function checks if the person object has a student ID property and returns true if it does. If the person object is a student, the if block is executed and the person object is narrowed to student, allowing you to access the student ID property without a compilation error. Otherwise, the else block is executed and the person object is narrowed to teacher, allowing you to access the employee ID property. Here are some best practices for using user-defined type guards in TypeScript. Use descriptive names for type guards. Name your type guard functions based on the type they guard against. For example, if you have a type guard for strings, name it isString. Use unknown instead of any. When using a type guard, it's better to use unknown instead of any as the input type. Unknown is a type-safe alternative to any that allows you to narrow the type of an object without losing type safety. Use object is type for return type. When defining a user-defined type guard, use the object is type syntax for the return type to indicate that the function narrows the type of the input object to the specified type. Combine type guards with control flow analysis. Type guards can be combined with control flow analysis to narrow the type of a variable or parameter within a certain block of code. This allows you to access properties or methods of an object that are only available for a specific type. Avoid complex type guards. Try to keep your type guard simple and easy to read. If your type guard becomes too complex, it may be better to split it into multiple smaller type guards. Use built-in type guards when possible. TypeScript has built-in support for type-off and instanceif type guards. Use them when possible instead of writing your own type guards. Document your type guards. Document your type guards in comments to make it clear what types they guard against and how they work. By following these best practices, you can make your code more readable and maintainable while still benefiting from the type safety features of TypeScript.